Hi guys, today we're going to talk about the associative property. And the I can statement we're working on is, I can identify when two expressions are equivalent. Let's look at the associative property. In this property, the numbers change who they associate with or change groups. And we can illustrate this with Elena, who likes to associate with everyone and switches lunch tables often. The associative property works with addition. Look at the first part of this problem on the left-hand side. The order of operations says I need to add what's in the parentheses first. So I would add 4 plus 5 to get 9, and then add 3 plus 9 to get 12. Using the associative property, I can change the parentheses, but notice the order of the numbers does not change like it does in the commutative property. When I rearrange the groupings, on the right-hand side of this equation, I would have to do 3 plus 4 first to get 7, and then add 5 to get 12. Notice in both sides of this equation, I get 12 as my sum. The associative property also works with multiplication. In this problem, I would have to multiply 7 times 8 to get 56. And then multiply 56 by 9 to get 504. Now on the right hand of this equation, I would have to multiply 8 times 9 first to get 72. 8 times 9 to get 72. And then multiply 72 times 7 to get 504. So on both sides of the equation, even though I've changed the groupings or moved the parentheses, but not the numbers, I got the same product. Let's think of some easy to add numbers. Numbers that add up to multiples of 10, like 10, 20, 30, 40, 50, and so on, make adding easier. Watch as Peg and Cat remind us what the multiples of 10 are.
Everybody take your trays and scoop up chickens 10 at a time, like this.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10 chickens.
I have a tray with 10.
I have a tray with 10. I have a
Big Mouth!
I do not have a big mouth. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Wahoo!
counting by 10. You can do any job that you need to do.
Counting by 10, she can count really high. She goes so fast. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. A shoo-be-dee-doo. I said 90. I said 100. Wahoo!
Woohoo!
That was fun. Now let's recall all the ways you can make 10. In the summary section of your WSQ, write down any patterns you notice on the list. You may need to pause the video so you can write all the patterns and examine the problems on the screen. But when you're done, hit play, because we still have more to talk about. So why is this useful? Well, the associative property allows us to change the grouping in an addition problem so we can add them easily in our heads. Let's look at an example. In this problem, using the order of operations, I would need to do what's in the parentheses first. So I would need to add 4 plus 2 to get 6. And then add 6 plus 8. Well, you could probably do 6 plus 8 in your head, or you might need to use your fingers, but either way, you would get 6 plus 8 equals 14. Now let's rearrange the grouping or move the parentheses, but not the numbers in this problem. So now I've grouped 2 and 8 together. While 2 and 8 are easy to add in my head, I know 2 plus 8 is 10. And because of the order of operations, I know that I need to add what's in the parentheses first. So now I have to think, what is 4 plus 10? That's much easier to do in my head because I know 4 plus 10 is 14. Now it's your turn. Rewrite the following expressions using the associative property to make it easier to add them in your head. In the work section of your WSQ, rewrite the expressions for 1, 2, and 3. Then rewrite each expression using the associative property so that it would be easier to add in your head. You may need to pause the video to answer 1, 2, and 3 in the work section of your WSQ. But when you're done, hit play again, because we still have more to talk about. You may be asking yourself, how does the associative property help us multiply numbers mentally? Well, the associative property of multiplication works the same way as the associative property of addition. You might want to start by looking for numbers that multiply to make multiples of 10, like 10, 20, 30, 40, 50, and so on, to make mental multiplication easier. Should we have Peg+Cat remind us of the multiples of 10 again? Okay.
Everybody take your trays and scoop up chickens 10 at a time, like this.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10 chickens.
I have a tray with 10.
I have a tray with 10. I have a
Big mouth!
I do not have a big mouth. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Wahoo!
counting by 10 chickens do any job that you need to do.
Counting by 10, teach you count really high. Take your soul fast. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. A shoo-bity-doo. I said 90. I said 100. Wahoo! Cheep, cheep, cheep.
Woohoo!
Let's look at some examples of multiplication problems that give us multiples of 10. 5 times 4 equals 20. 20 is a multiple of 10. 25 times 4 equals 100, and 100 is also a multiple of 10. 50 times 4 equals 200, and 200 is another multiple of 10. Remember, when you multiply by a multiple of 10, you need to have the same number of zeros at the end of your product that you have in the original problem. So what you're really doing is multiplying the first number, 3, times the first digit or the non-zero digits in your multiple of 10. So in the first problem here, I would think 3 times 1, which is 3, and since 10 has 1 0 at the end, I would put a 0 at the end of 3, so 3 times 10 is 30. When I get to a problem like 4 times 20, I would think in my head, what's 4 times 2? And that would give me 8. Then I put a 0 at the end because there's 1 0 in the number 20, so I get 80 as my product. 15 times 10, I would think, what's 15 times 1? That gives me 15. And since 10 has 1 0, I'd put a 0 at the end of my product. 4 times 100, I would think 4 times 1, that would give me 4. And since 100 has 2 zeros at the end, I would put 2 zeros at the end of my product. 7 times 200, I would think, what's 7 times 2? That's 14. And since 200 has 2 zeros, I would put 2 zeros at the end of my product. 23 times 100, I would think, what's 23 times 1? That gives me 23. And since 100 has 2 zeros, I would put 2 zeros at the end. So, the number of zeros at the end of the numbers I'm multiplying is going to tell me how many zeros I'm going to have at the end of my product. So why is this useful? Well, the associative property allows us to rearrange the grouping of numbers in a multiplication problem, so we can multiply them easily in our heads. Here's an example. If I wanted to multiply the quantity 3 times 5 times 6, I would first, using the order of operations, have to multiply 3 times 5, and that would give me 15. Then I'd have to take that 15 and multiply by 6. I may not know the product of 15 times 6 in my head, and I may need to do some scratch work. But after working it out off to the side, I would find out that 15 times 6 equals 90. Now let's look at how the associative property, rearranging the grouping or moving the parentheses, but not the order of the numbers, helps me to multiply this in my head more easily. When I rearrange it, I would take 3 times the quantity of 5 times 6. And using the order of operations, I'd have to multiply 5 times 6 first, and that would give me 30. So now I have to do 3 times 30. Well, in my head, that's pretty easy. All I have to know is how to multiply 3 times 3. And 3 times 3 equals 9. Since 30 has one 0 at the end, I know I need to put a 0 after my 9. So 3 times 30 equals 90. Doing it this way, I don't have to do as much work off to the side. I can actually do this whole problem in my head. Now it's your turn. Rewrite the following expressions using the associative property to make it easier to multiply them in your head. In the work section of your WSQ, write the problems for 5, 6, and 7. Then rewrite each of these expressions using the associative property, moving the parentheses, not the order of the numbers, so that you can multiply them more easily in your head. We are now done with this lesson. Pause the video so you can answer 5, 6, and 7 in the work section of your WSQ. Then go back and make sure that you have written your summary and a question that you or someone in the class might have about the associative property. You can go back and watch this video as many times as you need to so that you understand the associative property.